Alright, my little math friends, we are done with chapter 10 already. Now we're going to move into chapter 11. It's kind of the same thing. We're looking at data again. Our first part is going to be comparing data from a dot plot. Okay, so the first type of comparison we're going to do is comparing dot plots visually, just taking a look at what they look like. Alright, just trying to spot some differences, some things like that. Okay, just to let you know, when we're doing comparison like this, it's a little bit less math and it's going to be kind of wordy. Alright, so if you like writing, this is great. If you do not, then this lesson might not be as enjoyable for you. Okay, so let's take a look at what's going on. We have two dot plots here, and what these represent, the dot plots show the height of 15 high school basketball players and the heights of 15 high school softball players. Alright, so we got our softball players over here, we got our basketball players over here, and just looking at them we can see some differences. We can see that there's a lot of points kind of all bunched together here. This dot plot over here, we got 1 point off by itself. We have some points here, a gap, and then some other points over here. So there's some differences, and we're just going to go about looking at these differences. The first difference we're going to look at is describe the shape of each dot plot. One that kind of looks like this, where there's all the data kind of together. If we kind of drew something like that, they call this more of a bell shape. Okay, because it kind of just makes like a bell like that when all the data is together and you got that high point. So that's what we're going to put down for softball. You can call it bell or dome. Alright, the description doesn't really matter too much as long as you're accurately talking about what's going on here. And it makes like a bell or a dome. So let's write that down. So softball data is, and I'm just going to use dome shaped. Okay, and if we compare that to what basketball looks like, if we're looking at this data, we have like a small dome here and it kind of goes flat, and then we have a larger dome over here. Okay, they kind of call these peaks. Alright, so we got a peak here, a gap, and another peak. So if we wanted to describe what basketball looks like, this one's going to be a little bit more wordy because there's more going on. We would say data has two, we'll call them peaks, two peaks with a gap in the middle. We'll just say in between. Okay, so no matter how you word it, you could have said middle, you could have said in between. No matter how you word it is fine as long as you're able to describe it. There's no exact worded answer that's correct as long as you have an accurate description. Okay, so let's compare the centers of each dot plot. The center is where most of the data is. Okay, so here's our center here for the softball. Here's the center here for the basketball. Okay, so if we're going to compare the centers of each dot plot, we would just say where it is. For softball, the center is at 5 feet 4 inches. And for basketball, the center is at 5 feet 8 inches. Okay, so there's our centers. Compare the spreads of each data plot or each dot plot. So we want to look at how far the data is spread apart. Okay, so taking a look at how far they're spread apart for each one. Looking at the softball, these data points are obviously closer together, so we can say that data spread is closer together. Alright, and then with the basketball, looking at these two, this is definitely more spread out. There's more space between all the data points, so we can put that down for the basketball, that the data spread is further apart. Okay, so those are just 3 sample questions of how you can compare these two dot plots to kind of describe what's going on. All right, now let's take a look if we are going to compare these same dot plots, but we're going to do it using some numbers more than just a descriptions. Okay, so numerically means we're going to use more numbers. So we're still going to be looking at it, but we're going to use some more numbers to kind of represent what is going on. Okay, so looking at the shape of each of these, that's the first thing we're going to describe. Describe the shape of each dot plot. If we're going to use this more of numbers, we would talk more about the numbers here. So for softball, describing the shape, we have this this peak or the top of the dome, the bell right here at 5-4. So that's what I would want to say. I would want to say most of the data is here, and if you count up all the data, most of the data is right here on this side as compared to this side over here. There's 8 points here, only 7 points over here on this side. So that's what we're going to describe this as, to kind of describe it more using numbers. We will say most data is 5 feet 4 inches or more. Okay, it kind of puts some numbers to instead of just the shape of the dot plot. And this basketball player's height over here, looking at this dot plot, we have most of the data is here at 5'8", which is at the center, and we have more data over here on this side of it, and then we also have this gap in between, so we want to describe that also. So basketball has a little bit more we can describe. So this is going to be more writing. Most data is 5 feet 8 inches or higher. And then we can also talk about the no data here. No data at 5 foot 6 inches or 5 foot 7 inches. Okay, so just kind of put some numbers to the descriptions. Alright, comparing the centers of each dot plot using the medians. Okay, so in the last one we just looked at the center, which is right here where most of our data points are, the mode basically. So we want to now calculate the median and see how that compares with the centers. Okay, now I've already calculated the median for you, but because it would take me a while to write down all these numbers and show you on this video, and we already talked about how to do the median. So when you are asked to find this on your work tomorrow or the next day in class, just calculate the median, same way we did before. Start with your lowest number, and you just got to put them in order from smallest to biggest. So you would line those out. So my first one here would be at 4 foot 11 inches. Then my next data point is at 5 foot, and then I cross it off. Then I got another one at 5 foot. Then my next one would be at 5 foot 1. Okay, so you just keep listing them out. I don't need to list all those out for you. When you do list them out, and remember you cross them off from one side to the other till you get to your middle number. My softball the softball data comes out to, the median is 5 foot 4 inches. Now I can put a comma there, which is at the center. Okay, so my median just happens to be at the center where you can see most of the data. Sometimes that's the case, sometimes it's not. Basketball, it actually came out to the same type of situation. The median is where the center is, 5 foot 8 Alright, when I calculated that out, that's what it came out to, which is at the center. Okay, so there's looking at the centers and also taking a look at the medians too. These just happen to be right at the center. Sometimes that doesn't happen that way, so then you would describe it saying it's not if that isn't the case. Last thing we're going to look at is the spreads, but we're going to be using the range so that we could see some numbers behind this. So softball, we already know that there's less of a range here because the data points are closer together. So if we were going to calculate the range, let's just say there is less range, and then we would show the example. So our lowest point is 4 feet 11 inches to our highest point, which is 5 foot 6 inches. And if we calculate the range from that, then we get 7 inches as our range. That equals 7 inches. Okay, so that's my range for softball. If I want to do the same thing for basketball, this is going to obviously have a more range. Okay, because these data points are more spread out. We got our smallest number at 5 foot 2 inches, and it goes all the way up to 6 foot 0 inches. So that comes out to, if you count up the inches in between, the smallest to the largest, we get a range of 10 inches. Okay? And that is it for 11.1. Taking a look at dot plots using what they look like visually, and then using what they look like with representing them with some numbers. Okay? Don't forget to try this problem. I'll see you guys next time in class, and we'll look at some more dot plots for your assignment.